Hi, good morning. Welcome back to our physics classes. During the last few classes, we were talking about the current electricity, and we have seen the properties of charges under motion. And there we have defined electric potential difference, electric circuit, then electric current, then electrical resistance, then resistivity, combination of resistors and all. And there we have defined electrical circuit. Electrical circuit is a continuous closed path through which electric charges can flow. But to maintain a current through that circuit, one necessity is there. That means one necessary condition is there. There should be a potential difference between any 2 points within that circuit. Between any 2 points, within that closed path, if there is a potential difference, then only charges can flow through that circuit. The mechanism of current flow that we have already seen, we have defined drift velocity, relaxation time, and mean free path. All those matters we have already discussed. So you just remember that. So when you make a potential difference between any 2 points within an electric circuit, then only current is possible. So how you can maintain that potential difference between 2 points? So to provide a potential difference between 2 points, you are making use a cell. What is an electric cell? So here we start our next chapter. That next chapter is DC circuits and measurements. The chapter name is DC circuits and measurements. There we have to learn what is an electric cell and what are the possible ways that you can make use an electric cell. Then some useful measurements in an electrical circuit. Okay, so we will come to that, and we have to start with our new chapter, that is your sixth chapter, that is DC current circuits and measurements, DC circuits and measurements, which deals with obviously with the DC current, DC circuits and measurements, and we have to start with what is an electric cell and the properties of electric cell. Okay, so we have to start with DC circuits and measurements. So we have defined electric cell. So electric cell is a source of electrical energy which maintains a continuous flow of charge in a circuit. That is the definition given for electric cell. So electric cell is a source of electrical energy. It is a source of energy. What kind of energy it possesses? It possesses electrical energy which maintains a continuous flow of charge in a circuit, which allows the continuous flow of charges in a circuit. So from the lower classes you have learned what is an electric cell. So we can find different types of electric cell, but the purpose of electric cell is use of electric cell or the function of electric cell is same for everyone, every kind of cells. So cell is a source of electrical energy. Cell is a source of electrical energy. It allows the passage of continuous flow of charges through a circuit, which means it maintains a potential difference within the circuit. It maintains a potential difference within the circuit. So if you maintain a potential difference within the circuit, it generates an electric field. That electric field maintains a force on free electrons. Within that force, or due to that force, these free electrons are moving in a direction opposite to the electric field, which maintains a current in that circuit. So the purpose of electric cell is to provide a potential difference within the circuit in which it is connected, to provide a potential difference between 2 points within the circuit. So when a circuit is connected to a cell, you know cell is having two electrodes. One is having positive charge and the other is having negative charge. Positive electrode is known as anode and the negative electrode is known as cathode. Between these electrodes a solution will be there. The solution may be in some cells, the solution may be in the liquid form, some in the solid form. So anyhow, we are not going to the details of different types of cells, but you have to remember that there is a solution between the electrodes of the cell, which is known as the electrolyte. So electrolyte contains charges, free charges. So between the electrodes, charge flow is possible only through the help of these electrolytes. So electrolyte is a mixture of, or in a solution which contains ions, positive ions and negative ions. Anyhow, so we have two electrodes. One electrode is positive and the other is negative. So between the electrodes there is a potential difference. That potential difference is developed across the circuit when it is connected in that circuit. So that is the function of a cell in a circuit, to maintain a potential difference and allows the continuous passage of electricity or electric charges through that particular circuit. So that is electric cell. So when you have an electric cell connected in a circuit, obviously it allows the continuous flow of charges in that circuit. So to make charges flow in the circuit, the system has to do a work. Which system? The cell has to do some work. So the work done by the cell in forcing unit positive charge to flow in the whole circuit is called EMF. That is known as the EMF of the circuit. You are familiar with the term EMF of the cell. EMF, which means the work done by the cell in forcing unit positive charge to flow in the whole circuit is the EMF. So EMF is electromotive force. EMF is the electromotive force. It is the potential difference between the electrodes in an open circuit. It is the potential difference between the electrodes in an open circuit. It is denoted by capital E. It is denoted as capital E. So we have defined EMF. EMF of a cell is the electromotive force. It is known as the electromotive force. The force which motivates electrons to move through a circuit. That is actually electromotive force. The force which motivates electrons to move through a circuit. So EMF is the work done by the cell in moving unit positive charge through the whole circuit. So even though we are saying that current is possible only through the flow of free electrons, but here EMF we are defining the work required to move unit positive charge in the circuit. From the beginning itself we are taken unit positive as a test charge. That is why we are here also we are using the test charge as positive charge. So the work required to move unit positive charge through the whole circuit by the cell, work required by the cell or work done by the cell is known as the electromotive force. You can find another definition for electromotive force. It is a potential difference between the terminals of a cell. That means it is the potential difference between the electrodes when the cell is in its open circuit. Cell is in the open circuit. What do you mean by open circuit? Open circuit means there is no current flow through that circuit, which means no current is drawn from the cell. If a current is flowing through the circuit means from the cell current is drawing. From the cell the current is drawing. So if the switch is suppose a resistor and the circuit is the resistor, a cell and a switch is connected. Since the switch is open, which means no current is flowing, that means the circuit is not closed, continuous closed path. But now the circuit is not closed path, so there is no current flow through the circuit. Even though the cell is connected, a potential difference is there within the circuit, but there is no current flow since the circuit is not closed. So that is the condition for maintaining a current. We know we should have a continuous closed path with a potential difference. Now the circuit is continuous, potential difference is there, but it is not closed, which means no current flow is possible. Okay, so anyhow, when the switch is open, no current is flowing through the circuit. No current is flowing from the cell and no current is flowing through the circuit. Now when you are measuring the potential difference between the terminals, that is the electrodes of the cell, you can find the EMF of the cell. That is the EMF of the cell. Remember, it is the work done by the cell to move unit positive charge through the whole circuit. It is the potential difference between the terminals of a cell in an open circuit. Okay. See, now you can find another term, terminal potential difference. It is the potential difference between the electrodes of a cell when it is kept in a closed circuit, and it is denoted by V. Why terminal potential difference is defined in the closed path? Closed path means when current is flowing through the circuit. Obviously, when current is flowing through the circuit, some potential difference will be there between the terminals. That is the terminal potential difference, and it is denoted by V. So remember, EMF and terminal potential difference are same in one sense. In which sense? Both are the potential difference between the terminals of a cell. But what makes the difference there? The difference is terminal potential difference you are measuring within a closed circuit, and the EMF you are measuring in a closed circuit. So what makes the difference there? Now both in EMF and terminal potential difference, both you are measuring between the terminals, that means the positive terminal and the negative terminal. But what makes the difference there? The difference is defined by the third term that you can see here, that is the internal resistance. So the resistance offered by the electrolyte of the cell is known as internal resistance, and it is denoted as small r. I already told you there is a electrolyte present between two electrodes of the cell. So it's a solution, and that solution, chemical solution, and that solution is having positive ions and negative ions. So when the cell is connected in the circuit, current is flowing. So the externally from the cell, current is flowing through the circuit, and internally between the positive terminal and the negative terminal, current flow is possible. Then only the circuit will be again continuous and closed. So current is flowing through the electrolyte between the positive terminal and the negative terminal internally. That means through the inside the cell, current is flowing through the electrolyte between the electrodes, and externally current is flowing through the circuit between the electrodes of the cell. Are you okay? So when current is flowing through the external circuit, a potential difference will be developed across the external circuit, and since the current is flowing through the internal circuit also, that means through the electrolyte also, potential drop will be developed across the electrolyte present between the electrodes. So the electrolyte between the electrodes can offer a resistance. Electrolyte present between the electrodes can provide a offer a resistance, and that resistance which is acting between the electrodes within the cell, that is known as the internal resistance. Remember, wherever there is a resistance, when a current is flowing through that resistance, a potential difference will be developed. So when current is passing internally through a cell, through electrolyte between electrodes, and and potential difference is developed. Remember, externally we are taking the current flow from positive terminal to negative terminal. All those matters you have already learned, because actual current is flowing from negative terminal to positive terminal, but conventional current is flowing from positive terminal to negative terminal externally. The difference means how the difference comes. Anyhow, externally through a circuit, current is flowing from positive terminal to negative terminal. But when you consider the internal flow of current through the cell, internally current is flowing from negative terminal to positive terminal, which means the potential developed inside the cell is opposite to external potential difference. Are you getting my words? Externally, for a cell, I am talking about a cell. Externally, the potential difference of a cell is measured between the electrodes, and it is measured from positive terminal to negative terminal. That is, we are saying that EMF of a cell when no current is flowing through. But when a current is also flowing there, then what happens? A potential difference is developed across the internal resistance, and that internal resistance is opposite to the external potential difference that you have already measured within an open circuit. That is why we have to define the second term that I have shown you, that is the terminal potential difference. Terminal potential difference you are measuring in a closed circuit, which means whenever a cell is in the closed circuit, a current is flowing from the cell externally through the circuit, internally through the internal resistance, that through the electrolyte. So obviously potential, when you are measuring the potential difference across the between the terminals of a cell, in potential developed across the internal resistance which is in the opposite direction to be subtracted from EMF, that difference is the terminal potential difference. Are you getting now? EMF is the potential difference measured between the electrodes of a cell when no current is flowing, which means what potential difference you are measuring between the terminals when no current is flowing, that is the EMF. And suppose when a current is flowing through, a potential difference is developed internally through that cell, that is opposite to the external potential difference. So net potential difference will be what is measured externally plus what is measured internally, but internally you are measuring in the opposite direction. So actually what happens is, what is the net potential difference in a closed circuit is what is measured externally minus what is measured internally. That is potential EMF minus potential developed across the internal resistance. Are you getting it? I will show you in another way. So I think you are familiar with the three terms, EMF of the cell, terminal potential difference and internal resistance. So EMF of the cell is the potential difference measured between the terminals of a cell when no current is flowing, that in the open circuit. And when you are having a current flowing through the circuit, then the potential difference measured between the terminals of a cell when it is in the closed circuit, that is terminal potential difference. And the resistance offered by electrolyte between the terminals of a cell, which means internally, that is the internal resistance. Okay, now we have to find out the relation between E, V and R, that is EMF, terminal velocity and the internal resistance. For that, you see the diagram. See, you are having a cell of EMF E, with an internal resistance R. This is the internal resistance. So generally we are denoting a cell with the two parallel lines that you have already learned that. Two parallel lines, one is larger than the other. Which is larger? That is the positive terminal, and which is smaller, that is a negative terminal. And cell is connected with a resistance, that is its internal resistance. See, and this cell is connected through a key, a resistance R, external resistance R, and an ammeter. What is an ammeter? Ammeter measures the current flowing through the circuit. And here you can find a voltmeter. This voltmeter measures the potential difference between the terminals of the cell, also the potential developed across the resistance. At the steady state, both will be same. Okay, anyhow, when see the current I is showing there, from where it is starting, positive terminal. See, from the positive terminal it is flowing out, and the current is flowing like this through the resistance, and see coming back to this negative terminal of the cell through the internal resistance. Okay, so internally it is flowing from negative terminal to positive terminal through the internal resistance, and again that continues from the positive terminal it starts and flow through the external resistance and going back to the cell. Okay, so remember, always we are expressing the direction of the current from the positive terminal to the negative terminal. Okay, so suppose this is the condition. A cell of EMF E and the internal resistance R is connected to a key, a resistance and a meter. We can forget about this voltmeter and ammeter now, because ammeter measures the current I flowing through the circuit and voltmeter measures the voltage developed across R, and which is equal to the EMF of the cell at the steady state. Okay, anyhow, suppose the key is closed. Suppose the key is closed. When key is open, what will happen? When the key is open, circuit is there, potential difference is there, but it is not closed. So what will happen? No current is flowing through. So to maintain the current, what to do? You have to make it closed. That means the K should be closed. So when the key K is closed, current is flowing through the resistance R, which means the current I starts to flow from the cell and it flows through the resistance R, and it is measured by the ammeter A, and it comes back to the cell through the negative terminal. Okay, and when the current I is flowing through R, a voltage is developed across IR, and that is measured as V here. Okay, anyhow, by the definition of EMF, suppose during a time dt, dq amount of current charge is flowing through. Current I is dq by dt. So I we have defined, but when you are analyzing I, you can find that for a time dt, dq amount of charge is flowing through the circuit. That is why I is equal to dq by dt. Okay, so for moving the dq amount of charge, work should be done. What work should be done? Work required to move unit charge is EMF. So work EMF E. So work required to move dq amount of charge should be E into dq. Are you confused? No chance of confusion, because EMF we have defined as a work required to move unit positive charge the whole circuit. That is EMF, that is denoted as E. That is a work done per unit charge. But here we have told that dq amount of charge is flowing through. dq amount of charge is flowing through. So by the definition of EMF, what is the work required to move dq amount of charge? That is dw is equal to E into dq. What is dq? I into dt, because I is equal to dq by dt. So that will be equal to E into I into dt. Okay. Since the potential difference across R is V, dw externally is equal to V into dq. What is that? What is dw externally? The work required to move dq amount of charge externally. I already told you V is the potential developed across R. So when dq amount of charge is coming here, it experiences a potential V across Q. So through this potential, this dq amount of charge has to move. When a charge is moving through a potential, work is required. That is the external work done. So dw external is equal to V into dq. That is V into I into dt. Okay, because dq is equal to again I into dt. V into dq is the work done for moving dq amount of charge through a potential V. What is V? V is the potential developed across R. Then potential difference across the internal resistance. And the same current is flowing through the cell from negative terminal to positive terminal. That means the same current I is flowing through the internal resistance also. So a potential difference will be developed across R, that will be I into R, which is denoted as small v. Small v is equal to I into R. Remember, that is the potential difference developed across internal resistance. So work done, see W work done externally we have defined as capital V into dq. So since internally potential is I into R, what is the work done internally? That is small v into dq. Small v into dq will be IR into IDT. IR into IDT. That is internal work done. dW internal is equal to small v into IDT. IDT is dq. So I square R into dt. So two work done we have defined here, external work done and internal work done. What is external work done? Work required to move dq amount of charge externally. What is internal work done? What is the work required to move dq amount of charge internally of a cell? Okay, so the net work done, the dW will be dW external plus dW internal. But dW we have already defined as E into dq, that is E into I into dt. So E into I into dt, dW is equal to d external, dW external is V I dt plus I square R dt. So I dt is common in both, all the terms. So I dt will be cancelled. E is equal to V plus IR, or V is equal to E minus IR. What is these terms? What is E? E is the EMF, V is the terminal potential difference, and IR is the potential developed across internal resistance. So I have already told you, whenever EMF is measured, the current should be 0. That means current drawn will be 0. It is an open circuit. When terminal potential difference is measured, then that will be closed circuit. That means I is not equal to 0. See, the terminal potential difference V is equal to E minus IR. That I told you, terminal potential difference is the difference between the EMF and the potential developed across the internal resistance. That is V equal to E minus IR. So what is V? I into R, and what is E? E that is itself, and IR is IR. So I is equal to E minus R plus R. You can take minus IR term to the left hand side. So that will become I into R plus capital R. So I should be E minus R plus capital R. See, from this equation V, E minus IR, that you have to remember. V is equal to E minus IR. Okay, we have defined now the relation between terminal potential difference, EMF, and the internal resistance, that is V is equal to E minus IR. Suppose the cell is in the open circuit. In the open circuit, no current flow, which means I equal to 0. Then the terminal potential difference will be equal to EMF. E is equal to V. Suppose it is in a closed circuit. I is there. So V is equal to E minus IR. What it indicates? Terminal potential difference should be either equal to EMF or less than EMF. Less than EMF. When a current is drawn from the cell. Current is drawn from the cell. That means current is flowing out from the cell. Cell is discharging. So on discharge of a cell, or during the discharge of a cell, terminal potential difference should be less than in EMF of the cell. Suppose current is flowing into the cell. Current is flowing into the cell. Then what will become? I will become minus I. So V will be E plus IR. When it happens? It happens when current is flowing into the cell. Generally, we are using the cell in a circuit so as to take current from that cell. But sometimes the current, the cell is getting discharged. At that time, some kind of batteries you are having, cells you are having in some kind of toys or in your cameras and all. It's familiar to you that I am saying about these cameras and toys, and in there you are making use rechargeable batteries, is it? So when you are keeping it in for keeping the cell for recharging it, what you are doing? You are make to flow charge into that cell. That means current is flowing into the cell. At that time, you are not taking current from the cell, but you are taking or giving charge into that cell. Is it clear? That means when you are charging a cell, current is flowing into that cell. So, terminal potential difference will be more than its EMF. And when you are taking current from a cell, then what will happen? Then the terminal potential difference will be less than the EMF of a cell. So remember that equation, V is equal to E minus IR. When it is discharging, I will be positive, and when you are charging, I will be negative. Then that will become E minus IR in discharging and E plus IR in charging. Okay, so that is the relation between internal resistance, EMF of a cell, and the potential difference. That means the terminal potential difference. Okay. Okay, so we know what is a cell, and we have to define the three terms related to that cell. And you know, the cell, suppose you are having a torch cell and a remote cell or a toy cell, that are pencil cells. We are saying that it is a pencil cell. And when you are considering a cell like that cell you are having, so we are having different kinds of cells. So when you are considering a torch cell or a toy cell, see, this is a toy cell, means I have just taken from my son's toy, and he will beat me now. Anyhow, see, this cell is having a positive terminal and a negative terminal. In this you can see written as positive, and here it is written as negative. Can you see? Okay, it's familiar with you, means no extra definition or extra discussion is or description is required there. Anyhow, it has a positive terminal and a negative terminal. So when you are using a single cell, suppose the required potential, what is the EMF of this cell? The EMF of this cell is 1.5 volt, all of you know. So sometimes we need a larger potential difference or larger EMF, and for that these cells are not sufficiently enough. Cells are not sufficiently enough. So what to do? You have to take combination of cells. So combination of cells means if you are connecting this kind of cells together, that will lead to you for combination of cells. So combination of cells is known as battery. That is known as battery. But in daily life or in common language, we are saying this as a battery. When we are going for a shop for purchasing this one, even we are making a single purchase, we are saying buy a battery de do. Is it? Nobody will say that buy a Excel de do. So this is not a battery, this is only a cell. And the combination of this kind of cells, not this kind of cells, any kind of cells, that leads to combination of cells. That leads to a battery. So there are three different types of combinations. The two different types you have already learned. We have done that for capacitor, then for resistor, and now for cells. And that are series combination and parallel combination. See here, this is the diagram is showing the parallel combination of cells. Parallel combination of cells. Here when parallel cells are connected in parallel, R net will be, that is net internal resistance will be R by N. I already told you how this 1 by R should be 1 by R plus 1 by R plus 1 by R by 3 by R. Then R should be reciprocal, R by N. So R net will be small r divided by N, where N is the total number of cells connected. Then net EMF will be the EMF of a single cell, that I have told you. So R net will be the net resistance in the circuit will be, see, this net internal resistance is in series with the external resistance. So R net will be capital R plus small r by N. So I will be net EMF divided by net resistance. What is net EMF? NE. What is net resistance? R plus NR. That is the parallel combination. That is the parallel combination. Okay, so you can see when cells are connected in parallel, their internal resistance are parallelly connected. Net EMF will be EMF of a single cell. Then the current will be E divided by R by N plus R. When you are taking the numerator, cross multiplying the denominator, that will be small r plus NR divided by N. That N will go up. That is NE divided by R plus NR. That is the current flowing when the cells are connected in parallel. Now we can go for the third kind of combination, that is in mixed group. See, in mixed group what happens is there are n cells connected in series. N cells connected in series in a line. See, there are m number of that kind of series combinations. You have a series of n similar cells, and you have a parallel combination of m such series combination of n cells. Are you okay? So in each line there are n cells connected in series, and there are m number of lines connected in parallel. Okay, so in internal resistance in the first row will be NR, since internal resistance will be NR. Then in m that kind of rows, how many, what is the net internal resistance? That is NR divided by m, because internal resistance of each line will be NR. There are m number of rows. You just go to the last description. If R resistors are connected in parallel, then R net will be R divided by number of parallel combinations. Similarly, for one line internal resistance is NR. That kind of m rows are there. So the net resistance of the whole combination will be NR divided by m. And that total internal resistance will be in series with capital R. So R net will be NR divided by m plus capital R. That is the total resistance in the combination. Total resistance in the combination. Are you have any confusion? Don't go with any confusion. See, each line has an internal resistance NR. There are m that kind of lines with the NR internal resistance. So net internal resistance will be NR divided by m. Then it is in series with the capital R. So NR by m plus R is the total internal resistance. Total resistance in the circuit. And E net will be what is E net? NE, not E. E net will be NE. You make the okay. E net will be N into E, because in one line N cells are there. So NE is the total EMF in one line, and there are m lines. Since they are connected in parallel, what is the total EMF in one series? That will be the E net, that is N into E. So I is equal to net EMF divided by net resistance. What is net EMF? NE divided by NR by M plus R. When you are cross multiply, it will become NR plus MR divided by M. That M will go up. So I will be M and E divided by NR plus MR. That is the current in the mixed group. Mixed group means parallel combination of series combination. Mixed group means parallel combination of series combination. So go through it thoroughly, carefully. there is a chance of confusion, but there is no chance of confusion. So R net is equal to, in one row R net will be NR. There are M such rows. So our total internal resistance will be NR divided by M. Then that is in series with external R. So NR by M plus R. E net will be NE. Then I should be NE divided by NR by M plus R. Why E net will be NE? In one line N cells are there. So there, since they are connected in series, their EMFs are adding up. So NE. And such NEs are in parallel. So NE will be the net potential. So I will be NE divided by NR by M plus R. That will be MNE divided by NR plus MR. Remember, N is the total number of cells in a series and M is the total number of such series in parallel. Simple way, M is the total number of lines and N is the number of cells in each line. Then it is simple. Okay. So that is the combination of cells. So we have seen series combination, parallel combination, as well as mixed group of combination. So that all about cells, EMF of a cell, potential difference, internal resistance, relation between them, then combination of cells. That is a battery, combination of cells. Okay, so that's all for today, and we will meet in the next class.